Alright guys, so the last video that you saw was the first page of that set of notes on circles, which is really kind of all your notes for this unit are all in that one booklet, except for the definitions we had in that first sheet. And that first page, we're looking at circumference and how to get it forwards and backwards. And if you flip over to the other side of that first page, you'll see that we start talking about something called arc length. And you already remember from your definitions what the arc is, right? The arc, I said it's like an arc-en-ciel or a tir à l'arc. It's like a bow, right? You have a chord that's like the line that connects these 2 points would be the chord, and this would be the bow of your archery bow, right? So your arc is just part of the circumference of the circle. And on the second page, let me get it looking in a way where I can mess with it a little bit. On the second page, you see it says that the arc length is just the distance for part of the way around the circle. Really, this is just a percent of the circumference, right? This is pretty common sense. You say to yourself, okay, if I know the formula for getting the total circumference of a circle, in this case, I can say, well, radius times pi times 2 will give me the whole circumference. That's what we saw on the last page. Then if I'm talking about the arc length, and the arc length is just part of it, then I can just get part of the circumference, right? Like if the arc is half the circle, if I had, for example, something like this, if I had, okay, my arc is going to be this much of the way around the circle, you can say, okay, well then I'm just going to calculate the circumference, and then I'm going to multiply it by a half, or 0.5, or 50%, or whatever it is, and that'll give me this arc length, right? Because the arc is just part of that circumference. Or if instead of going half the way around, I just went a quarter of the way around, and say, okay, well, if I want to know how long this is, then let me get the whole circumference and multiply that by 1/4, or by 0.25, or by 25%, something like that. And that's really just what we're doing here. Except when you think of the way that people measure how far around a circle you are, and this works with compasses when you're lost in the woods or if you're in the Air Force and anything like that, there's a bunch of different ways people talk about it. Like in dogfights in the Air Force, they'll say, "Oh, you're at 10 o'clock," which means the guy's right around here because that's around 10 o'clock on a clock, right? And when we're dealing with circles, the way that we mostly deal with it is when we talk in terms of degrees. Like this right here, this angle, this central angle of this circle, you could think of it as just, well, it's 33.3% repeating of the circle. That's what the angle is. But instead of talking in percent, we talk in terms of degrees. It really works kind of the same way as percent, except if a percent is just a fraction over 100, then a degree is just a fraction over 360. Right? So when you say 120 degrees, you could think of it just as 120 per 360 instead of percent. Cent means 100, right? So 120 per 360. That's just what the degree sign means. And really, if you just think of it in terms of that way, then it becomes pretty easy to calculate arc length. So the way to think of it is this way. Let's say I had an example like this. Oh wait, that's the